So, yes, we'll continue with the library, but before library, I'll just give you one definition of dynamic polymorphism. Write it down. Long back, I should have given this simple definition to you. Okay, write it today. You write it where you know. Dynamic polymorphism notes is there now. You write this there actually. So, what is dynamic polymorphism? A very simple definition I'll give you. What is dynamic polymorphism? Any answers? Huh? Simple answer for this one. Binding what? Subclass object with superclass reference variable is only dynamic binding. Binding subclass object with superclass reference only is called as dynamic polymorphism. This is the most important point. Remember this. This is the most important definition of dynamic polymorphism. A very simple definition. You know how to do it now. Write superclass, write subclass, binding, all that you know. Just one simple definition for dynamic polymorphism I give it to you. Yeah. What is dynamic polymorphism? Binding. You understand a binding? Binding subclass object with superclass reference variable is called dynamic polymorphism. Yeah. Okay. Now we'll get into the library. Actually, this point you write it in dynamic polymorphism. You have written notes now. There you add. It will be easy for you when you read. Okay. We'll start getting into the library now. I'll be taking the first package now. Okay, that is, so Java has got a very huge library. Java.lang package is there. Okay, then you got Java. So many packages are there. We are covering the Java package today. The main package we are seeing is Java. In that sub packages are which one? Java.lang, Java.util and Java.sql. We'll be covering this. So these are the very important packages which developer has to know. Again, in packages what we'll have? Classes. Okay. So last time I told you how to explore the libraries. Understood? One, you can go to the website. Okay, and in website you can find what? The description about all the classes which are present in lang package. I'll just type and show you now. Yeah, like that you can see. Or one more command you can use. Java P. Both I've told you. Okay. We'll see that. See, from certification point of view, SCJP point of view, these two packages are highly mandatory. Okay, this will be used for another certification, we'll see it. But from certification point of view, SCJP certification you want to do, till now what you learnt. That plus these two packages if you learn, then only you can write a SCJP exam. Understood? Till now what you covered, that is still interfaces, inner classes and all that. Plus these two packages if you cover, then only you can write SCJP exam. So we'll start off with lang package now. Now if you want to get more information about the lang package, you can get into which one? Website and type java.lang. Okay. So docs.oracle, you'll get this. So here java.lang. If you want, you can click on frames. Okay. So here you'll find all the packages now. These are the packages of what? Okay, if you want you can select all the packages here. Java.lang package if you select. So these are the set of classes and interfaces, correct? And if you go to classes, now I'll be going with the first class which is called as object. So in the library you'll be picking the first class, that is object. There are many classes here, clear? So if you select the class called as object, see here it changes, that side. So there you select the package, here you select the class, here it will display the members. Understood? So we are going to study all the members of what now? Class, object. Understood? So every day it will be the same story now. So after this, till inner classes, there might be a variation in explanation in books. But after inner class completes, okay, any book you take, they all explain you what? The same concept. They will also be explaining the library, but for explaining this library, they will be using their own examples. That's it. So we are also going to do the same thing. We are going to see this library, but with the help of some examples now. Clear? So this is the constructor, it's a class object is having one constructor, and these are the different methods. Last time I told you how to go through the library. Okay, these are the difference. Clone is a method of what? Class object. Return type of this is what? Object. This is a protected method. Similarly, equals is a method. Argument what you have to pass is object. Return type of this method is boolean. If you want to click more information, you'll get here. See this, it's called on, that's it. I'll give you more information about that method. This is the description of the library. Means if you use this method, this is the logic it contains. If you use this method, this is the logic. We don't code anything now. Okay, so when you want to develop an application, there are many things which are ready-made now. So we just have to use it. So it's a paradigm shift. Paradigm shift means, or it's a transition phase now. Okay, we are moving from language into library. Means we have got a very powerful programming language, and Java says you can use it to write code. Initially they are telling that, but now they are telling what? Do not code anything. Instead, use the library. So it's a transition phase now. After learning language, every other language is what you do? You learn programming logics. But here, what you will do? You learn to use library. You don't write the logics. So it will take some time for you to get adjusted. Say 1 week, 10 days, slowly you will get adjusted. Then you can write anything now. So this transition phase is very crucial now. Understood? This transition phase is very crucial, and once you understand this, then you can start using the library. So like this it will go now. So I'll be going and getting into this library now. So once I complete object, then I'll be going into what? Example, string class. Then I'll be going into what? String buffer class. Then I'll go to string builder class. Like this, one by one, we'll start seeing all the classes now. Okay. Then integer class is there. All I'm teaching is that only. We are going to explore the library. Clear? So this has been given to you in your DVD. You don't have to log on to everyday internet. Okay. It has been given to you in your DVD. You can copy it into your local machine. That time every day will not need the internet. Understood? So tomorrow I'll show you how to copy paste it and all this into which one? Your local computer. Actually it is there. I've shown you I think last class. See D drive. Sorry. In this one cluster softwares API. I showed you this now. JDK 1.6. API docs index.html. See, this is old documentation. When Sun was giving the documentation, they are giving it in this style. After Oracle took over, they are giving it in that colorful format. You saw it is a colorful format now? This was the colorful format. Like example, see this. Here I type just on java.lang. So you can see here, after you can see docs.oracle it is. Earlier it was Sun, but now it is Oracle. See here, this is the difference. This is how Oracle has changed, but this is how earlier it was looking for you. How it was looking? Like this. Here I'll show you. It was looking like this. Means there is no color, no frames you click always, it's better. See now, same thing, there is no change, but only a little bit Oracle has modified the view, that's it. Lang, in Lang what is there? Object. Same story. Both are same, there is no difference. Clear? Okay, so the same thing we are going to study now. So you can, it is given to you in your DVD, you can copy it and paste it into your local computer. Okay, so just double click, you'll get the screen. And one more thing, you can add it to your favorites, because every time you don't have to go to index.html and search it. Add it to your favorites. How will you add it to the favorites? How will you add it to the favorites? Favorites you say? Favorites. How to add?
Favorites. Actual favorite. Yes, without.
You just say add. So that's it. From next time onwards, what you do? Just open your browser. Okay. Only favorites. You click, automatically it will open up. Understood? Means you don't need internet now. Just add it to your favorites. Otherwise, every time you'll have to go to index.html and open it up. Clear? So done. So the next time onwards, what I'll be doing? I'll be looking in the local machine itself. So what is Sun doing is, for all the classes they have written, they have prepared documents and they have hosted onto the internet like this. Anybody writes a class in Java, they'll prepare a document and host it into the internet, because if they don't give us the information about what the class is doing and all that, how will you use their class? So after the class is ready, they'll prepare the documents for it. Clear? So one more way, if by chance internet is not available to you, documentation is not available to you, one more way what you can do is, you can go to the DOS prompt. See here, CMD, here you type Java P. Java P means Java profiler, it is called Java profiler. Okay, anyway, Java C is the compiler, Java compiler, Java is the exe file. For this you have to give what? Fully qualified class name, java.lang.object. Java.lang.object. We give the fully qualified class name, it will give the list of all the members. This is an emergency case, but it will only give the list of the members. It will not tell you what method is doing what and all that. Okay, for all that information can be only seen in the documents. Okay, so now what you can do, same thing what I have done, say I have copied and pasted all this. You know how to copy paste now? Last class I showed you. See, these are the members of which we are going to study now. Copy this, you can open on Edit Plus and you can say File, New, Java you say, and paste it, because there it's here, it's cleanly visible for you. Okay, so these are the members. What are the members now? Just see this. This is one constructor, only they are using fully qualified class name. So this is a constructor. Now what is this? Get class is a method. Return type is class, no parameter. Native you leave, that keyword I have still not taught you, but other keywords you know, public and final you know. Understood? Similarly, native is another keyword, leave it, but hash code is another method. Return type of this is what? Hash code is another method, return type of this is int. Okay. Similarly, equals is one more method. Parameter what it requires is an argument of type object, like this. Okay. So like this, these are the members. So I'll go on to explain you these members now. So we are looking into the members of class object. Clear? So I'll start off. And it's a paradigm shift. It will take some time for you to understand. Immediately in one day, you will not get adjusted to this. Okay. So here you'll have to start putting a lot of effort now. Okay. Then you'll start understanding how to use this library. Even though you feel very happy, what? All code is ready-made. But fact is, all code is ready-made. You don't know what logic you require for coding. When you don't know what logic you require for coding, how will you use the library? So that is where the problem comes. So you don't know any logic. Generally the logic what you know is adding two numbers, multiplying two numbers, these kind of logic, or ascending order, descending order. Okay, apart from that you don't know any other logic. But while coding an application, there are many other types of logics we require, and all that logic you can start seeing it in the library. So one by one we'll start seeing now. So in the first package we'll go now. Yeah, see this Lang package, exploring the Java library. Understood? That's the title now. So we are getting into which package? Lang package. We are getting into Lang package. So java.lang package is built in Lang package, provided by whom now? Sun. We are starting getting into the library now. It's provided by Sun itself. All the classes of this package can be used directly because they are imported into all programs. See, this is the only package which gets imported into all the programs. Any other class from any other package you have to import. Till now you are importing. Now why did you do import? If you want to use a class from one package into another package, you are doing import. But this is the only package for which we do not do any import. And all the classes of Lang package are by default imported into every program. Like till now you have used string class, which are system class, integer class we used. Okay, but till now we did not import any class, even though they are kept in the Lang package. But other classes which are kept in other package we are importing, like P1 package, P2 package we are importing. Okay, so now that's what Sun is telling. Because why it is telling do not import anything? Because this package contains classes which are required for very normal basic program. So that is why in all your programs now, by default what will be happening is this statement will be added during runtime. Import java.lang star will be added. Supposingly I am writing class demo program, class demo PSVM. So automatically what happens? All the classes of Lang package will be imported. That's why we are using here. What you are using? See, this is how your code will be. See, we write the code like this. I might put this into package P1. I'm putting the demo into package P1. So here we are having public static void main string args. We are having this. So once you are having this, here see, we are using the built-in class string. Then I am using one more class, system.out.println. But system is also one more class now. Where are these classes coming from? We did not import. So by default, all the classes of lang package are imported. You don't have to worry. But any other class in any other package, you have to import it explicitly. Understood? Only this one. Okay. So since during runtime, what will happen is when you run the program, the JVM will add this import java dot import. This will be added during runtime now. Import java dot lang dot star will happen. But we are not writing this line now. Are we writing this line? We don't write this. So a developer does not write this line. Developer does not write. Okay, but it is added implicitly. It is added implicitly by JVM. This line will be added implicitly by JVM. Clear? So we'll get into the first class now, that is object. So system is on built-in class, you use string is on built-in class, clear? Huh? You already used. So since it contains classes which are required for even the basic simple Java program also, so that's why they are imported implicitly. So put the first heading class object in the library. Now write class object is the superclass of all classes in Java. Class object is the superclass of all classes in Java. See here, class object is a superclass of all classes in Java. Means till now we are writing no class box. We are writing no class box. So class box is extending which one? No, actually object only. The name of the class is object. Don't get confused with our object. Our object is which one? Code coming into existence. Our object means the normal object what we are talking till now. So that object is nothing but code coming into existence. If you want, you can create an object of this class also. If you want, you can create an object of this class also. This is name of the class. Don't get confused. Clear? Fine. So class box, even if you don't write extends object, by default it will be extending what? Object. So this class is loaded into the JVM. Okay, when this class is loaded, you know when the class is loaded into the JVM, no? When you start saying new keyword or something, the class is loaded into the JVM. As soon as it is loaded into the JVM during runtime, I mean to say, during runtime, the class will extend object. The JVM will add it. So this actually during runtime it will be changed as what? Extends object. So all the members of superclass will be available to what? Your subclass. So class box becomes a subclass of what? Object. Class box becomes a subclass of object. Even say you write class box weight extends box, yes or no? You are writing what? Class box weight extends box, yes or no? But again box weight is extending what? Box. Box is extending which one? Box. Object. Like this it continues. You are writing class shipment extends what? Class shipment extends box weight. Again it is indirect. Means how? Shipment extends box weight extends box extends object. Like this you see all classes will be subclass of what? Object. This is one hierarchy. This story is going like this. You got the object class and here story is like this. Box. Box weight is extending box. Shipment is extending box weight like this. Supposingly if I write class hello. Now class hello is not related with what? Box also, box weight also, shipment, but it is also subclass of what? Object. Supposingly I write class test. So it is also subclass of what? Object. You will write class demo many times. Class demo. Demo is also subclass of what? Like this. Every class is a subclass of object. Getting the hierarchy tree now? Okay, any class. Similarly, other built-in classes are there. String will be a subclass of what? Object. Okay, other classes are there. Integer. This class, that class, all are subclass of what? Integer class. Any class in Java you take. Your class, built-in class, any class is a subclass of what? Object. First you have to understand this. So getting used to the library is difficult. So it takes some time. Clear? So any class in the world is a subclass of object like this. You take anything. Okay. There is one more class. Most important classes I am writing. The name of the class is what? Class. This is also a subclass of what? Object. Any class, system class, this class, any you name the class, it is a subclass of object. Understood? Now, since it is a superclass, what can happen? Since it is a superclass, it can refer to any subclass object now. All are subclasses of which one? This one. So this code is highly valid now. If I write object E is equal to new box of 1, 2, 3 is highly valid. Superclass variable can refer to what? Subclass object, dynamic polymorphism, or object E1, this is object E1, object E2 is equal to new string is also valid. Just examples I am giving you, we'll see about all this later. Okay, so object E2 is equal to new string, object E3. So E1, E2, E3 are what? Variable names is equal to new integer of 10. This is also valid. Are you clear? So this is how, so that's what I am telling you. Once again, are you clear this code now? Superclass means a variable of type object can refer to any subclass object. A variable of type object can refer to any subclass object. So are you clear with all this? Okay. So now we'll start seeing the class object in a very clear way. So now why it is the superclass of all classes, you might have a question, correct? It contains some common functionality required for all the classes. Some common functionality is there, like hash code and comparing two objects. Okay, there are some common logics which you'll understand. So that logic is present in this particular which are class object. Okay, well, the different kinds of logic are here. We'll see it. The class object is the superclass of all classes in Java. I'm going to first neat heading now. This is an introduction to class object now. Class object is the superclass of all classes in Java. A reference variable of type object can refer to an object of any class. Okay, a variable of type object can refer to an array also. It can refer to array also. Because arrays are also what? Objects in Java. Object E is equal to new int of 5 is valid. Object E is equal to new int of 5 is valid. We'll be seeing that. Okay. The class object provides some common features to all classes. I was telling you now. See this. Comparing, cloning, notifying, converting into string. These are the common logics required for what? Okay. Many classes, all the common logics required for all the classes has been kept in class object. Because everybody will get it inherited. Any class will get this property now. That's their idea. Fine. So we'll go with the first member now, called as which one? Get class. So these are the members. Let me show you again very clearly. So the members are, you open in edit plus, it will be neat and clean. What are the different members? Finalize is on method. Return type is void. Equals is on method. Return type is boolean. Like this, so many members are there. And notice here very clearly, these members are what? Final members. These are final methods. Means you cannot override. Some methods I'll override today. Understood? Why we override and all we'll understand. So these are the final methods. So you cannot override. Final methods cannot be overridden. Yes or no? Final methods cannot be overridden. Now more things. See, among how many methods, final methods are there? Count 1, 2, 3, 4, 5, 6. 6 final methods cannot be overridden. 6 methods. So totally how many methods here? Totally there are 11 methods. Totally if you see there are 11 methods. Among the 11 methods, 6 are final methods we cannot override. And in these 6 final methods, these 5 methods are related to what? Are related to multi-threading. 5 final methods are related to multi-threading. So these 5 methods I will not cover now. I will be covering the other methods. Okay, why I will not cover this? Because when I am covering multi-threading, I will cover those 5 methods. Understood? So then these 6 methods we will see now. Okay, and we will learn one by one. So you can learn it in any order, that's your wish. Okay, so we will learn the first method, that is get class. This is the first method we are going to learn now. So it's a final method, we cannot override it now. It's a final method, we cannot override it. Let's see how to use that method now. So what is the logic it contains? Understood? Some logic is there, and obviously if it's a method, what does it contain? Logic. So that is given to you in the library itself. Let's see what logic it contains, how to use it and all. We'll start seeing now. Are you clear with all this? So we'll start seeing. So this one method we can't override, but these 5 methods we learn now. We can override. We can override these 5 methods. Which one? Finalize you can override, equals you can override, hash code you can override, toString you can override, clone you can override. So one by one we'll learn how to override it also and why to override also. Understood? We should know why to override also and how to overload also. How to override you know now. Sorry, not overload, override. How to override also we should learn now. How to override you know now. Signature should be same. That's it. Method name and signature should be same, then we'll override. That's it. Let's see now. We'll continue. Are you clear with this? Any questions? Okay, so we are going to first method now called as get class. What is get class now? So it returns what? Is a final method in class object. Okay, and it returns the class of the object. So that's what it tells in the library also. But what is the meaning of this? See, now I'll go to this and we'll see now. You're seeing the library. So it tells what we are going with the get class now, which is the method name get class. So it says returns the runtime class of this object. But what is the meaning of this now? Question is that correct? Huh? So yes, let's see. If you want, you can click. It tells you more information. But you cannot understand this so easily. The library. You can see very complicated statements are there. Gradually you start understanding this, because more you explore the library, then you start understanding this. So that is why you are here now. Why you are paying money and learning Java is for this reason, because first of all you don't know whether library is there in Java or not. Second thing is you don't know how to use the library. So whatever you are learning now is only learning how to use the library itself. Clear? So now this is what it says. So but it is not understandable to you. Slowly you start understanding. But let me explain to you now what is get class. Clear? So fine, let's see what is get class now. So in the class called as object, the one method which you are studying is now get class method. The return type of this is what? Class. That's how you have to understand first. Now what is class? One more user defined type. You know now returning object. One more, the return type of this method is class. Means one more object of type class. One more object of type class. We have seen how to return box object. We have seen how to return test object. Now it will be returning similarly what? Class object. Understood? An object of type class. Understood? Now let's see first. So we are going with this method now. So assume that I have two classes here. Class box int whnd. I'll have the constructor also. This is the constructor. You know how to write it. Write it. This is the volume method which I have. Now I'll have class test. So like this you'll write plenty of classes in your program now. It can have int x, int y, it can also have its constructor, it can also have its method, void m1 method. See, these are the members of, see, these are the two classes, box class and test class. Generally, how do you use them? Generally, how do you use them? You say box B is equal to new box of 1, 2, 3. You will create an object like this. And you will also say, so again, sometimes you might say, yeah, then you might create the other object. Test T1 is equal to new test of 5, 5. You are creating two objects. After creating the two objects, okay, again if you want you can create more objects. Box B2 is equal to new box of 10, 20, 30. You can create more objects. Or you can write test T2 is equal to new test, I write something like 10 and 10. So what are you doing? You are creating the box object as well as you are creating the test object. Again you created the box object, again you are creating the test object. Like that you will go on creating the objects. See, objects can be created n number of times. There is no problem with that. Once you have got a class, what will you do? You will go on creating the objects. But what you have to understand is, see, first when we coded this program, okay, there will be 3 dot class files which are generated when we compile. After coding this program, we will compile. Okay, and there will be 3 dot class file, box dot class, test dot class, demo dot class. So all these dot class files are lying where? In the hard disk. All these dot class files are lying in the hard disk. So exactly what happens now, see, when you type Java demo, what happens? Java command will start execution, means Java is nothing but JVM. JVM starts off. As soon as you type in the DOS prompt, what? Java, this one starts off, JVM. Now the JVM will use the class path and load first which class? Demo.class into the JVM. Demo.class into the JVM it will load. After loading demo.class into the JVM, it look for in main demo class which method it will search? Main only. Your demo class can have many methods. Not only main, it can have M1 method, M2 method, many it can have. But in the first class, always main method only is searched. Means, I'll be explaining you this flow still more clearly. Which one? Java demo. In fact, we have studied all this. As soon as you say Java demo, what happens? Java command is starts the JVM, demo.class is loaded into the JVM, and in this class, main method is searched. So, one way of loading a class into the JVM is what? Java command. What are the different ways you can load a class into the JVM? What are the different ways you can load a class into the JVM? One is by using the Java command. Other way is you can use the new keyword to load the class into the JVM. Other one is you can use when you access a static member. So a class is loaded into the JVM under these 3 conditions. But Java command is used to load the class which contains main method. Java command is used to load the class which contains the main method. Okay. So this command is used for only loading one class. Which class? The class which contains main. After that class is loaded, that class will load other classes now by using what? Either new or by accessing the static member. So like this, the dot class files one by one from the hard disk, they will start getting loaded into the JVM. Are you understanding the class loading concept now? Yes. So once the classes are loaded, see now, the class is loaded only once into the JVM. Remember that. The class is loaded only once into the JVM. But you can create 1000 objects of the same class or n number of objects of the same class. We have seen all these points very clearly. A class is loaded only once, but objects are created n number of times. Okay, I'll give you plenty of examples for this. Next, so when that happens, so let's see what happens. See, as soon as a class is loaded into the JVM, okay, implicitly, I'm telling implicitly now, an object of class gets created. An object of what is getting created? Class. We are talking about class object. The heading is class object, I know. But in that we are studying one method called as which one? Get class. So the return type of this is what? Class. So the return type of this is class. So that is why I am explaining which one? Class. Okay. Today I am not covering class. Okay. Today I am not covering class. I am covering class object. Understood? So in detail I will be covering class later. Okay. But just understand, as soon as any class gets loaded into the JVM, an object of class gets created. Implicitly, I cannot create an object of class. You cannot create an object of class. An object of class is created implicitly as soon as any class is loaded into the JVM. Means here box B1 is equal to new box. Here in this line what is happening? Two things are happening. One class is also getting loaded, other one is object is also getting created. Two things will happen first time. So when you say box B1 is equal to new box, see, these are the members of what? Class box into W. As is your class, same way your class will be loaded now. How you have written your class, same way it will come into, means it will be loaded. Supposing I have written my class in this way, same way it will be loaded. Then it will contain what? Volume method. So this is loaded. So this is a definition. Understand this very clearly. I'll clear all this. See, this is definition of class. This is definition of what? Class box. This is definition of class box. See, objects have to be created, but how should the object be created? It needs the definition. JVM needs the definition, so it will load it. And this is the definition. So as soon as this is loaded, an object of what gets created? See, this is an object of class. This is an object of class. So this object of class, what it will contain? See this clearly. It contains information about the loaded class. This is also an object. This will also have an address, something like 555, some address it will have. Understood? Some address it will have. Okay. So then see, first box B1 is equal to new box. Your definition of the class has got loaded into the JVM. Are you clear with this now? 1 second, man. What does this object contain? Contains information about the loaded class. Here, which is the loaded class? Box class. It will contain all the information. See, this is containing info, and address will be something like 555. Okay. So see, first box class got loaded into the JVM. Then object of class gets created. Then what happens? Your object is getting created. Which one? Box object. So it will have W, it will have H, it will have D. You are sending the values now. 1, 2, 3. So these values will be here now. 1, 2, 3. So this is how the constructor gets executed. Okay, and this is the B1 object. Understood? So it will have the members. Which members? You are having volume method and all that. Now it will be having all the members. So an object gets created like this. Okay, fine. So now class box is a subclass of which one now? Object now. Class box is a subclass of which one? Object. So see here, you are having the superclass members now. See, when you create the box weight object, it will have box of members now. When you create the box weight object, it will have the box members. Similarly, when you create the box object, what will have? It will have the superclass members. Which one? Box members. So what are the members now? One of the member present in superclass is class get class. This is the method what we are studying now. So what does this contain now? This method, okay, it contains the address. Supposingly this is one variable, built-in variable C. It is having the address of what? This particular object 555. So return C it will do. Address, it will return the reference value. More than that it will not do anything. Understood? So it is there now. See, this is how your box object is there now. So once you create the box object, what are the members you can call now? You can access all. What are the members? B1.w you can access, B1.h you can access, B1.d you can access now. Yes. Now you can also call which one? B1.get class. Following now. Once you say B1.get class, return type of this is what? class C. C1 or something you can take. Simple as that. So you are getting the reference to that object. Since we cannot create an object of class, I can only get the reference to the object. Reference to which object? Class object. I can get the reference. How do I get the reference? By calling the method get class. That's it. I'll get the reference now. Understood? Similarly, see now, next. So assume that after this line I have written next is this line. Box B2 is equal to new box. This has already been loaded now. Class box has already been loaded. Only what happens? One object of box gets created. What are the members of this? It will also have W, H and D. Just roughly I am writing now. It will also have what? Volume method and all that. And it will also have what? Get class method. Yes or no? Return type of this is what? Class. So here also I can say return C. Means if I say B2 dot get class also. If I call the method in B2 dot get class also, what is it going to return me? Class C2. Like this. So see, there is only one object of class per class which is loaded into the JVM. Understood? Means for box class there is one object of class. Next, if I say test T is equal to new test, what happens? Test class is loaded into the JVM. Another object of class will be created now. Same story for that also. Understood? So how many classes are loaded into the JVM? Those many class objects get created. Are you following now? How many classes are loaded into the JVM? Right now how many classes are loaded into the JVM? Box class and test class. So there will be two objects of type class. But box objects you can create n number. Box B1 is equal to new box B2 is equal to new box B3 is equal to new box. One more object of what gets created? Box. So you create any number of box objects, but there is only one object of what? Class for which one? Which contains the definition of class box. Understood? So how many objects of class are created now? How many objects of class will be created in a program now generally? It depends on the number of classes which are loaded into the JVM. Understood? It depends on the number of classes which are loaded into the JVM. Clear? So how many classes are loaded into the JVM? Those many class objects are created. Now what is the use of this class object? See, remember, always every class encapsulates one information. Yes or no? Yes. So this class contains information about this one. Which one? The class object contains the object of class contains information about which class? The class box. It contains information about this. Understood? Like it will give the name of the class. If you want, it will tell you which class it is, the name of the class. Then it can tell you how many variables are there, how many methods are there. There is one process called as reflection, which I'll be explaining you later. Okay. So if you want, you can get the information about the class using which class? Class. If you want the information about class box, you can get the complete information about class box using what? Class. We can get it. I'll be showing you how to use class very shortly. Okay, but right now what I'm telling is I'm not discussing class what it is. I'm only telling you how do you get the reference to that class object. How do you get the reference to the class object? Are you clear this? So get class method will return you what? The reference to the class object. That's what we say. Okay, but if you see the document, they put it in a simple way by telling what? It returns the class of the object. But actually it will be giving the reference of the class object. Understood? So every loaded class will have an object of class getting created. It will be created. Shall I clear all this now? We'll see it with program now. And initially it is bit which one? It will be bit it will take some time for you to get adjusted to this environment. Okay, so gradually you get adjusted. 2-3 days you'll get adjusted. Yeah? Okay, shall I clear all this now? So we'll see it. I'll type you and show you this program now. Then you'll understand this clearly. So 1 second. Yeah, 1 second. Just see this before I complete it. We said box B1 is equal to new box now. 1, 2, 3. B1 dot get class. I can call now. Return type is what? Class C. SOPC. You print. What it prints, you know? The name of the class it will print box. So again class has got many other members, okay, which I'll be showing you later. Now class also has got many members, okay, that I'll be showing you later. So we'll start coding today. What you do, you start using Eclipse only for all this. So in Eclipse what you do, you go to Eclipse examples, August 2013, Ravi Kumar, Java examples, yes, same place, core Java. Here what you do, you create one folder today called as lang package. So all the classes related to lang package will be stored here. Yeah. So in lang package what I'll do, one more thing today, see, to avoid confusing names, I'll just rename one folder. Okay, we'll do it renaming later. Package examples, sorry, which one? Lang package, na? Yeah, lang package you take. What you do, you open Eclipse today, create the folder first. It will be easy. Paste. Same dot metadata gets created there. Clear? Now this becomes the workspace. So store all your programs related to lang package here. Okay, so it will get created now. It is opened. First time always you get this screen. Close this. Go to Java environment. Java perspective you say. Close all unwanted things. Yes. Now see new project. I'll give the name as what? Object class. We are studying object class now, so we'll give the name as object class. Finish. So here what I'll do, what are the different members you are studying now? All the methods you are studying. So one of the I'll create one package now, com.cluster dot get class is the package name. Means com.cluster dot object dot get class, means com is the company, cluster is the company, object means we are studying the object class, get class is the method I am studying. Say finish. So it will be very clear for you. Now this package contains the example for what? Get class. So right click, new class, what will I give the name? Get class demo, or you can write only demo class, no problem, demo. I need main there, fine. So this is it. But now we have to write some classes now. Once again we'll increase the font sizes. See, while coding it becomes very simple now. New class, I'll write as what? One second. New class, I'll box. Okay. So, sorry. What will it contain? Int width. If you want, you can generate the constructors. Depth as we not. Where did the depth come? Okay, so now you have got the constructor here. Okay, so then you can write the volume method. See, all this is normal. You know how to code. There's nothing big about this. Concentrate on what? Get class method today. See, this is how you write your normal classes. Okay, there's no problem with this. Class box is ready. Now in the same package I'm creating one more class called as test. I can have some more members like int x. Example I'm writing int y. Like this you'll write many classes. Then also you can have a constructor for this. You can have one method. This is normal way of writing your classes. You will go on writing. So this is done. Now see, let's use this. See, how do you use? All the classes are in the same package. You don't have to import anything now. So start creating the object box. B1 is equal to new box of what? 1, 2, 3. You can create an object. Done. Next box. Okay, 1 second. We'll work with one object first. So I created the box object. So if you run the program, it will execute also. Run as Java application. Okay. Window show view console. You enable console if it is not, you are not seeing it. Okay, right click, run as Java application. Okay, we are not printed anything, sorry. Sys out. Okay, fine. Just I'm printing hello. You can run there. So it prints hello. Program is running, fine, no problem. So what you do, now I'll say this here. B1 dot, see the list of all the members in box, width, height, depth are the members of class box itself. Equals is a method coming from where? Class object. Get class is a method coming from class object. So these are all the members coming from class object. See the right hand side very clearly tells object, 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 object. These are all the members coming from class object. Okay, I'm working with which one now? Get class. So this get class is the method I'm choosing. This is the description of the what you are seeing in the documents now on internet. Same information it is giving you here. You can read it here also. Okay, so all that you'll slowly understand, but just I'm clicking on get class. Return type of that was what? Class C1. See, I am calling get class method now. As soon as I say get class, see what happens. Value of C1 is, now see, plus C1. Now see what happens. What it prints. So it is giving you the fully qualified class name. What is C1 printing? Fully qualified class name. So it is containing that C1 is a variable, or it is referring to an object of class. The object of class is containing complete information about which class? Class box. So I cannot create an object of class explicitly, but I can get the reference to that object by calling get class method. I can get a reference. And this is a very important class. So using this class, there is one process called as reflection. Okay, I'll be covering class next. Okay, that time you'll understand. So using this class, I can get the complete information about what? Class box. How many variables are there, how many constructors are there, how many methods are there, all that information I can get. When I'm using teaching you class, I'll teach you that. Reflection. Understood? Anyway, just see this now. Next, test T1 is equal to new test of 10 comma 20. See, now again I'll say T1 dot get class. Return type is what? Class C2. Done, no? So value of, sorry, value of C2 is plus C2. Now see, C2 is giving you information about what? Test class, fully qualified class name it will tell. So if you want, supposing you have an object and you have a reference variable. Every reference variable will be referring to an object. But if you want to find out the reference variable is an object of type what, just call get class. You get the complete information. Are you clear? So this is how. Now where it is used. Next questions will be obvious. When you start coding an application only, you'll understand all this. Okay, when you're coding applications, all this requirement will come. Okay, so that time we'll start using all these methods. Just we are exploring the library now. After we explore the library, we'll start developing applications. In applications, you'll understand exactly where they are utilized. Clear? Okay. Are you clear with this? See, now one more object I'll create. If you want, box B2 is equal to new box of 5, 5, 5. Okay. So now again, if I want, I'll say class C3 is equal to B2 dot get, sorry, yeah, B2 dot get class. Again, if I want, I can print. What I'll print? C3. C3 value will be same because it's of type what? Box itself. Like that. Anytime you want, you can call it. On any object you can call it. See, C1 and C2 are of type what? C1 and C3 are of type box. C2 is of type test. Fully qualified class name it will be. Yeah? Next. Yeah? So one side you have to understand what is library. Second side we have to understand where exactly this is required in an application. So since you are not coded an application, I told you, you don't know what are logics required for an application. So that is why you will not understand where it is used, why it is used. So once we start developing applications, then you will start getting the idea where it is used, why it is used. Understood? Clear? Shall I close all this now? So get class is over now. There is nothing more about get class method. It returns you an object of class. Or in simple, according to the document, what they say is a final method in class object. It returns the class of what? The class of the object. B1 dot get class. It returns the class of that object. T1 dot get class. It returns the class of that object. Clear? Okay. Now next method we'll take now. Finalize. I think finalize we have seen plenty of examples. Just we'll revise it. It's a predefined method in class object. Yes, I'll give you plenty of examples on this. It can be used for doing what? Finalization. Finalization is the final task which will be performed by an object before an object gets destroyed. If you ask me what's finalization, it is a final task which is done by an object before it gets destroyed. Now see, it is, why do you override finalize now? It is generally overridden in subclasses to clear the object level resources initialized in the object. Okay. Now next, it is called by the garbage collector on an object when garbage collection determines there are no more references to the object. It is executed only once on dereferenced objects during their destruction. You know all this? Just one more example I have to give to this. I'll give it and finish it off fast. Okay. So example C now. Supposing I have one class A. So I'll have one constructor here, SOP. I'll just write code actually. Later on you have to initialize. Okay. I'll write initializing resources. Just see the flow, how the finalize method gets executed. See now class A is a subclass of class object now. Class A is a subclass of what? Class object. All of you know that. So I can, once it is a subclass of class object, I can write my own logic here inside, using resource. What will M1 be doing now? It will be using resource. Whatever resource you have got now, like database connection, file connection, you'll be using the resource. What will M2 method do now? It will use resource. So all these classes go on to use what? All these methods will be using the resource. But somewhere you have to release the resource. Where will you release it? In the finalize method you have to release it. Can I now here SOP releasing resource. We are only printing SOP here, but later on you'll understand how to release it. You'll write the code. So this is how actually you write code in classes. You'll have a constructor, you'll have methods to use the resource. Now constructor has been designed to execute only once. Methods can be called n number of times. Now this will be called only once during the destruction. So I'll take the help of the constructor for what now? Initializing the resource. Methods are used for writing business logic. This will be used for releasing the resource. So all this you know now very clearly. Understood? So now why don't I release the resource in one method like fun method or show method like that? Because if you release the resource in one method called as fun and show, it is your duty to call the method for releasing the resource. Explicitly you have to do it. So since we don't want to do it explicitly, we follow on standard. Java people are telling all of you follow on standard. You just write your resource release code in finalize method. We will clear the resource by calling the finalize method implicitly. That's what their message is. Clear? So if you want the code for this, very simple. See what will I do? A1 is equal to new A. One object is created, means resource is ready in A1 object. Object is created, resource is ready. A2 is equal to new A. Like this I can create any number of objects now. A3 is equal to new A. Objects are created, resource is ready. A4 is equal to new A. Object is created, resource is ready. Later on after creating the object I can use the resource A.M1, A1.M1. I can go on using the resource. In scene A1 only I am using the resource 3 times. If I want I can use the resource of in M2 also. It goes on. But now if I call system.gc, will the garbage collector come? Yes, it will come, but it will not collect any objects, any dereferenced objects. Why it will not collect? Because there are no dereferenced objects. Understood? System.gc, it will come, but it will not collect the dereferenced object. But now I will dereference. How? A1 is equal to null. A2 is equal to A3. So 2 objects are dereferenced. Now if I say system.gc, garbage collector will come and collects what? 2 different objects. But before collecting the dereferenced objects, it will execute what? Finalize method on both the dereferenced objects. So in Java is one very good language which says only bother about allocating memory, don't bother about destroying memory. So if at all you want to destroy memory in Java, we only abandon the objects or dereference the objects. Once the object is dereferenced, that object is eligible for garbage collection. But before the garbage collector destroys the object, it invokes finalize method on that particular object. It's very simple process. It invokes the finalize method on that dereferenced object. Clear? That's all about finalize now. So it's on standard method. See, the garbage collector is not executing M1, M2 in your object. It is only executing which one? Finalize on your object. So that's why we follow the standard. So even if you write your resource release code in some other method, it will not be executed. So that's why we write it in finalize. That is the standard we follow. Clear? Okay. So if you want to see the output, you can see now. So all the points about finalize we have discussed. Now see, let's put it into coding now. So now in the same project, you create one more package. Very clearly you'll understand. New class. Okay. It will be demo again. For which one? Finalize. Okay. You can give name. Fine, no problem. Finalize demo. What is the package name? com.cluster.object.finalize. Like this, give good package names, then only you'll understand, else you'll not understand anything later. Okay, anyway, we'll write one more class here called as what? I told you every class will be kept in what? Separate Java file. So what is the name of the class? A, but it will be kept in which package? Same package. So say finish. I don't want main there, fine. So here just what we wrote, that only I'll code. A, constructor. None. So you can write many methods which can use the same resource using the initialized resources. The methods will be generally using the initialized resources. We won't write very logics very shortly, that time you'll understand this. Now you are supposed to override now, yes or no? So what are we doing now? Overriding. When you override, what is the rule? The signature should be same, yes or no? So I cannot write SC and all here, I have to write what? ZD only, then only it's called as overriding. And when you override, the access specifier should be what? Equal or higher. So you can see in the members, finalize is having what access specifier? Protected. So either you can make it protected or you can make it as public. We generally make it as public. We'll have equal or higher access. Public void finalize. So sys out. Yeah, so we have written the class now. So we just have to use it now. Let's see. So you can go on creating the object. A1 is equal to new A. See, like this you can create any number of objects. I have created 4 objects. So when I run the program, what happens? 4 times the object gets created. Now see there. So in the 4 times the constructor gets executed, and you can see the resource will be initialized. So after that, if I call system.gc, anything will happen, na? What is system.gc? System is a class. GC is a method, static method, like that. We are using the library. Understood? Slowly you'll understand how we are using the library. I'll call the garbage collector. Okay, nothing happens. You cannot see the finalize getting executed because they are not dereferenced. Okay, so in Java we can only allocate the memory. We cannot destroy the memory. If you want to destroy the memory, abandon the object or dereference the object. So fine, after calling that, a1.m1 method I can call. Fine. Again if I want, I can call a1.m1 method. Fine. Again if I want, I can call a1.m2 also. You can call any method anywhere, that's your wish. Or you can call a2.m1, that's your wish. You can go on calling the methods. Which method you want, you call from whichever object you want, because there are 4 objects. So we are using the resource, yes or no? 4 times I call the method, 4 times you are using it. So methods will execute n number of times. Constructor only once. Now again I'll call system.gc, nothing happens. Are there any dereferenced objects? Are there any dereferenced objects? No, you can see here. Still the finalize method has not got executed. But now I'll dereference. You know how to dereference now? A1 is equal to null. A2 is equal to null. How many dereferences are there now? 2. If I'll say A3 is equal to A4. Now I created 3 dereferenced objects. So now if I call system.gc, definitely what happens? 3 times finalize will be executed. 3 times. Because there are 3 dereferenced objects. So constructor execution depends on the number of objects you are creating. Finalize execution depends on the number of dereferenced objects. Clear? And finalize is called implicitly. We should not call finalize explicitly. If you call finalize explicitly, it will only release the resource but it will not destroy the object. Java does not provide you any mechanism for destroying the object explicitly. Anyway, there is one subject called as memory management. There I will explain you clearly about all this. We have seen life cycle of object. We have to see life cycle of memory management. There very clearly I'll explain all these topics. Here anyway the topic was finalize method. Okay, so what is finalize now? Is it clear? Finalize is a predefined method present in class object and it is used for releasing the resources. So you should know how to use the library. So the second method we completed. Which one is that? Finalize. Clear? Okay. Now we'll continue with the third method. Which one? Equals. There is also one more method which is present where now? Class object. So this method also will be overridden now. Why we override? We'll see this. Clear? Yeah. So before I talk about that, just look into this. See, it is used to compare what? Equality of two objects. Supposingly I'll have two objects. I want to check whether they are equal or not. Okay, means the state of the object. I want to check whether the two objects are having equal state. I will explain what is that. Means box B1 is equal to new box of 1, 2, 3. Box B2 is equal to new box of 1, 2, 3. Now I want to check whether B1 and B2 are equal. If you want to check whether B1 and B2 are equal, we can override equals method. How and all I'll explain this to you. Okay. So now let's come to this point. If you want to compare two primitive values, okay, we use what? Comparison operator. If you want to compare two primitive values, we use comparison operator. It compares the values in those variables. Understood? So we'll see now. It's all about checking equality. Okay. So see this. First of all, why do you use finalize method? To check the what? To compare whether two objects are equal or not. That is why we use equals method. But in detail I have to give an example. See, you open any document, that's what they are telling. Any document you open, they go on telling you this method contains this logic, this method contains this logic. Okay. To give you a demo for that, we give examples. That's how we are learning the library. Understood? See, class demo. Now first we'll see how to compare two primitive variables. Primitives. I'm talking about primitives. Int A is equal to 10. Int B is equal to 20. How do you check whether A and B are equal or not? If A is equal to B, this is how you check. Yes or no? If A is equal to B, this is how you compare to which one? Primitive variables. So the comparison operator actually checks what? Is the value of A equal to B? That's what it checks. Okay, is the value of A equal to B? Definitely they are not equal, it says else condition will execute. Here in this case what executes? SOP not equals executes. Yes or no? But if B is 10, if condition executes. So it's very easy to check what? Whether two primitives are equal or not. But now let's bring a condition here now. See, I'll write class box or I'll write class test. We'll check for class test. It will contain two variables, int x, int y. Two variables it will contain. It can have one constructor also. Fine, if you want you can write other members, that's your wish. But I want to check whether these two, see now, I'll create two objects. This is for primitives. Now see here, test T1 is equal to new test of 10 and 20. Test T2 is equal to new test of 10 and 20. Test T3 is equal to new test of 5 and 5. Now I want to check whether T1 and T2 are equal or not. My requirement is what? I want to check whether T1 and T2 are equal or not. Understood? So how do you check now? See, this is for primitives, remember. This is for primitive variables. Now we are talking about reference variables. Checking equality of reference variables. So if you want to check equality of reference variables, okay, let's see what happens. Okay, see, I can use which one? If T1 is equal to T2. Okay, what will it be checking? See, there are three objects now currently. This is T1, this is T2, and this will be T3. There are three objects. So T1 contains the values of 10 and 20, T2 contains the value of 10 and 20, T3 contains the value of 5 and 5. These are the three objects which I got created. But the address of this is 150, the address of this is 250, the address of this is 350. Now if I say T1 equals, means if I use the comparison operator, what will it check? The value in the variable it will check. What are the value? T1 is containing what value? 150. It will check with what? 250, and it says not equal. But I don't want, and it is actually right now what it is doing is, if you use comparison operator with reference variables, it is not giving a wrong output, it is giving correct output. You are using comparison operator with which one? Reference variables. If you use comparison operator with reference variables, it will check whether the reference variables are referring to the same object or not. It will check whether it is referring to the same object or not. Yes, correct, it is not referring to the same object. Is T1 equal to T2? No, they are referring to different objects. Understood? So else condition will execute now. Understood? SOP, which condition will execute? Else condition will execute. Understood? But I don't want to check whether they are referring to the same object. My intention is what? I want to check whether they are whether they are containing same values or not, whether the two objects are containing same values or not. Understood? So that is when what you do. Can you guess? So here it checks the reference value. If you use comparison operator with reference variable, checks what? The reference value, and checks whether both are referring to the same object. So it will be false only. Okay, but my intention is what? I want to check whether they are referring, means whether the state of both objects is same or not. That's when what you do? You can call the equals method. Okay, but if you call equals method, the default implementation also is containing the same logic. The default implementation in class object contains what logic? The same logic. Okay, I'll show you. Okay, so it will also give you false. But I don't want that logic. So I want what? Instead of that, I want a different logic. That's why we override the equals method. So I'll show you how to override it. Okay, then we'll discuss about all these topics now. Are you clear? So first I'll show you the output without overriding. Okay, then I'll tell you when you override what happens. Okay, so now see, equals is one standard method now, which will be called by any developer. Generally when he wants to check equality of two objects now, blindly he'll call what? Equals only. So do not write your equality logic in M1 method, M2 method and all that. If you write it in M1 method, M2 method, what happens? Other users will not call that method. They'll always call what? Equals method only. So if you don't write it in, if you might write the logic in other methods, M1, M2. But if you write it, what happens? He will not know what logic you have written, because it's a tendency of any user to call which method? Equals only. So if you don't override, which method will be called? The method from superclass. Okay, so be careful. If you want your logic to execute, you override it. We'll see it now, what we do. With an example only you'll understand. So again you can create one more project now, package. Form dot cluster dot object dot equals is the package I'll create. Okay, so create more packages. You'll understand which code is there in which particular class now. So I'll have one class called as test. So what are the members it contains? X and Y now we took. Int X, int Y. You can have constructors for this. Okay, your class is ready now. We'll try to check the equality. See this hint. I'll write P is equal to, or we'll take, int P is equal to 10. Int Q is equal to 20. See how you check the value, means compare with two primitives. You generally write like this. If P equal to Q, so you know this, if they are equal, they are not equal. Okay, so now we'll run the program. See, this is how you check, compare equality of two primitives. They are not equal, yes or no? Everybody knows this, there is no big thing about comparing what? Primitives. Okay, if I again say 10, yeah, it will tell what? They are equal. This is okay, but let's see how do you compare what? This is clear now? Okay, I'll just comment this, lay this now. Yeah, now let's start off with this one. Test T1 is equal to new test of 10, 20. So I created an object. Next, if you want, you can create one more object, T2. Yeah, T3. Three objects you are creating. But in T3 the values are 5 and 5. See, now I want to check whether T1 and T2 are equal, or T2 and T3 are equal. So what should I do now? So if I use this formula, if and else, see what happens. If T1 is equal to T2, now see what happens. What will it tell? Even though it's containing the same value, it will tell what? They are not equal. Because it will be checking the reference value. They are equal, but the state of the object is equal, but they are not referring to the same object. So this one checks actually what? It checks whether both the reference variables are referring to the same object. Both the reference variables are yes or no? And they are not referring, it's correct only whether both the reference variables are referring to the same object. It's correct only, there is no problem with that. Understood? It checks whether both are referring to the same object. Okay, even if I compare T1 with T3, still not equal only, anyway they are not equal. Okay, so it will be checking the reference value and it will tell no, it is not equal. That is correct, but I don't want to check whether they are referring to the same object. I want to check whether the state means the value stored in the object is equal or not. So that's when I can call T1 dot equals method. See this, I'll comment this. So now what I am calling T1 dot, I'll call the method equals, you know what is the return type of that method? Equals of, the return type of that method is boolean. You can directly call it like this, or you can write what? Boolean b is equal to T1 dot equals of, I can pass T2. This is also valid, and I can write directly what? If b also I can write. Okay, if b also I can write. Understood? So this is one way you can write, or otherwise you can write if I just comment it. But these are both valid statements only. or directly you call it here. The return type of that is a Boolean value. Still it will tell what? For T2 also it will be what? They are not equal. But it's not giving me any wrong output. See there? Blindly I can call equals. Blindly I am able to call which method? Equals. Why? See, in test class have I written equals method? No, I have not written. But it is coming from where? Superclass. Class object. It is coming from, I can call it. But it's giving me false. Okay, whether I check with T3 or whether I check with T2. It tells they are not equal. So this equals method of the class object or the default implementation of class object is containing what? Same logic. It will be comparing the reference value only. It checks whether T1 is referring to T2 only. I'll show you how they write the logic. It's the same logic they are written. But I don't want that logic to execute. I want some other logic to execute. That's when what we do. We override it. So I'll show you how to override it now and how we write the logic for checking the equality of two objects. Just see this now. Very simple. Just write public Boolean return type. Okay. Equals is the name of the method. Yes. The parameters of type what? Overriding means what? What is overriding? You know the rules for overriding. Same name, same parameter, same return type, everything should be same. Only access specifier can be equal or higher. So fine. Now see, for this method I can send any object. So it will come now. So but before comparing the two objects, first we have to check whether it is of the same type now. See, now when I ask you to check whether two objects are same or not, first you have to check whether the type of object is same or not. Now can I compare hello object with box object and tell they are equal or not? No. So to compare first what? They should be of same type. They should be of same type. After they are of same type, then we'll check the state in the object. After they are of same type, then we check the state in the object. So that's what I'll do now. Here you can send an argument of any type. Because what? Parameters of object means what? It can refer to any subclass object. But what will I do? I cannot directly typecast. So first what will I do? Now you have to do typecasting. Why will you do typecasting? To access subclass member. All the basics till now what you learned is coming into picture now. Understood? So I'll check if E instance of test, then what will I do? I'll typecast E to test. Yes or no? Test Z is equal to test of E. E will be typecasted to type test. Understood? Else means if you pass some other object, box object or some other object, what will you do? This if condition will not execute. It will tell else SOP sorry pass the correct object. But remember, you have to return one value here. You have to return what? One Boolean variable. So 1 second. Let's correct 1 second. Boolean B is equal to false if E instance of test Z is equal to test of E. So if condition executes, provided it's of type test. But after typecasting, now you have to check whether the value is of same or not. So then you write here, see here, again you write one more condition. If Z dot, okay here, sorry, Boolean B is equal to false. Else what will you do? B is equal to, sorry, directly you say return B. You'll return false now. See, this is how you go on writing logics now. Okay. So otherwise see if Z dot, what is the value? X. Z dot X and this dot X. Z dot X is equal to this dot X and Z dot Y is equal to this dot Y. B is equal to true, return B. Else see, understand very clearly, this if, this else, for this if, this else. Understood? I'll explain the code how it works now. Yeah? So this is how you write the logic. You override and you check one by one whether the value of x is equal to this x, whether the value of y is equal to this y. And if all are correct, then you'll say what? B is equal to true, return B. Else you'll return what? False only. B is false here, no? You'll return that. Okay. If you are passing a different object directly, you'll return what? False. So let's see this code now. Sorry, test now. Test T1 is equal to new test of 10 and 20. Test T2 is equal to new test of 10 and 20. Test T3 is equal to new test of 5 and 5. Now see what happens. See, when you create the test object, see what has happened. X is there, Y is there, everything is fine. But it is having what? On constructor, forget that, no problem. But it is having which method? Equals method. Now this equals method contains what logic? Whatever you have written. So here what is the logic you have written? Just some sample part of it I will write here. If, see, E will be typecasted to what? Test. Directly I will write the code. Or how will I write? Same code comes into existence, man. If E instance of test. So now what happens if E instance of test? Fine, next. Here what am I doing? I will typecast test Z is equal to test of E. Then if Z dot X is equal to this dot X and Z dot Y is equal to this dot Y. B is equal to true, return B. Else return B. And just shift this logic this side now, and 1 second I'll write it here. And Z dot Y is equal to this dot Y. Okay. So this is how the object is created. Then if is over, one more else is required. Else return B. See, this is how the object has been created. This object is called as T1. The address is 150. Yes or not? An object is what is created now. See, test T1 is equal to new. What is new doing? Allocates full memory. Constructor is executed. 10 and 20 are passed to constructor. So what will the constructor do? Initializes the instance variables, and the values of x and y will be initialized to 10 and 20. This is no problem. Okay. So once it is initialized, next what happens? You are creating one more object of type what? Test only. Same way one more object gets created. It will also have x, it will also have y, it will also have test. Same story will be there. It will also have equals method. It will also have object E. Same code will be there. Boolean B is equal to false. Here also same code. If E instance of test, no change. If Z dot X is equal to this dot X and Z dot Y is equal to this dot Y, B is equal to true, return B, else return B. One more if, this one more else, return B. So this is T2 object. Address is what? 250. The address of this object is 150. The address of this object is 250. Similarly, one more object gets created. Which one? T3. I will not write full story now. Here it's having what? 10, 20. Here it will have what? 5, 5. Like this, 3 objects have been created. Now say, I'll just call T1 dot equals. So if you are overriding, your method executes now, not the superclass one. If you are overriding, your logic gets executed. What is the argument you are sending now? T2. Now E is a variable of type what? Object. See, you have invoked this method T1 dot equals. Now you are sending the argument of what? T2. T2 is having what? Reference value. So the value of T2 is given to which one now? E. So E will refer to which object? This object. Superclass variable can refer to subclass object now. Fine. So now E can refer to it. But can I access the subclass members? No. So that's why what I'll do, I'll typecast. But before typecasting, I'll not blindly typecast. I'll check whether it's of type test. If it is of type test, then I'll typecast. Now what happens? This Z variable is referring to the same object now. Typecasting. Z variable also will refer to the same object. Now I'm checking Z dot X. Z dot X means what? 10 is equal to this dot X, means the current object dot X. 10 and 10. Z dot Y 20 is equal to this dot Y. Correct. 20. If both are equal, what will happen? B is equal to true, return B. Else it will return what? False. Like this it goes on. So anyway, T1 dot equals of T2, if I write it in Boolean B, what it will be? True. But if I say the same way, T1 dot equals of T3, what happens? False. T1 dot equals of T3, because see, now the address of what is given? This value will be given. So E will refer to which one? This object. You will typecast. Z dot X is what? 5. This dot X is what? 10. Z dot X is this time what? Because Z is now referring to which object? This object. So it will be what? False now. Because 10 is not equal to 5. Understood? So like this, it gives you the result as false. Understood now? So this is how we override it. If you know, the advantage of overriding is whenever you want to check the equality of two objects, see if you don't override, if you do not override this, okay. Now what would have been the problem? Now see, I'll create the object of test. If you do not override, what will happen now? If I ask you to check the equality, how will you do it? How will you do? You have to write it in some other class, yes or no? How will you check that? If T1 dot X is equal to T2 dot X and T1 dot Y is equal to T2 dot Y, you have to write the logic like this. Other way, if you don't override it, this is the logic you have to write. Now you are comparing here T1 and T2. After T1 and T2, if I ask you to compare T2 with T3, again you will write the logic now. If T2 dot X is equal to T3 dot X. Now later on I will ask you to compare T1 with T3. Again you will write the logic now. So instead of writing the logic 1000 times like this, it's better we write it in a single place like this. So I'll write it in a method. But the question is, what is the method name I'll give? Should I give it as M1 method or fun method or equals method? That's the question. You understood now? Here if I start doing this, for every object I have to go on writing the logic, which becomes a big headache. So instead of writing it like this for all the objects, what we do? Instead of comparing it for all the objects, so I, the developer of this class, what will I do? I'll only write the logic. So when I write the logic, I decide to write that logic in equals method. Why? Because that's a standard method. Whenever anybody wants to check the equality, no, they'll not call any method. Blindly they'll call which method? Equals. They'll not look for any method only. You might have written here plenty of methods, fun method, show method, M2 method, M3 method. User will not call. If at all he wants to check the equality of two objects, all he'll be doing is calling equals method. So that is one standard method what Java says. Use it for checking the equality, and anybody will directly do what? They'll call this method. If you don't override, which method will be called? The superclass method. Okay, and you know what is the logic of superclass they have written? Can you guess? In the superclass equals, they are not writing any logic. If they are only checking like this, if this is equal to, can you guess? If this is equal to E, return true, else returns false. This is the logic they are writing, nothing else. When in the class object, this is the logic. They are checking the reference. You'll send some address now. It will check the current address. It will check with what? The incoming address. If both are equal, it will return true, else it will return false. That's the default implementation. So if you don't want that, then we override this. Understanding now? So I'll type and show you this. So this is how you start writing the logics. We start using the library. Okay, so to check the equality, we'll start overriding what now? Equals method. So whenever you want to check the equality, start overriding equals method. Are you clear? Shall I clear all this? Okay, so I'll clear all this and start writing it for you. Clear? Any questions here? So you can now, once you write it, it is easy now. You don't have to write the logic again and again. Anytime you want to compare two objects, what you will do? Simply call equals method. Else what would have been the problem? You have to write the code again and again every time. T1 dot equals of T2 dot x, or T3 dot T1 dot x is equal to T2 dot x, T2 dot x is equal to T3 dot, like that. For every object you have to go on checking the equality. Instead of writing this redundant code again and again, we have written it in a method and given the method name as equals. One standard method now. See, Java follows some standard. For releasing resource, the standard method used is finalize. For checking equality, the standard method used is equals. They are following some standards. Understood? So where developers will never get any difficulty. So whenever you have two objects, and if you want to check equality of two objects, blindly call what? Equals method. Even in string also you do the same. Yes or no? Class string. String s1 is equal to yes hello. String s2 is equal to hello. S1 dot equals of s2 you call no. Where is that equals method coming from? From superclass. So they are overriding in class string. So like that, when we start using the library, you'll understand all this. That's the practical implementation of what? Equals. That's the practical implementation of equals. We'll be seeing all this. So we'll clear all this and I'll start and typing you and showing you this result now. You're understanding now, if I don't override equals method, what would have you done? See, if equals method is not overridden, or if you're not writing the logic here in the equals, what is the way you compare now? The only option is this. See here, if t1 dot x is equal to t2 dot x and t1 dot y is equal to t2 dot y, this is for what? t1 and t2. Again for t2 and t3 you have to write one more. If t2 dot x is equal to t3 dot x and t2 dot y is equal to t3 dot y. So this is for t2 and t3. If I want to compare t1 and t3, again one more. Now if there are 100 objects, can you go on writing the logics like this again and again? Instead of that, just write one place, use it whenever you want. And that too standard method now. Standard, because see, when for checking equality in one class, if you write in one method, now users will get confused now. You might write your class, you might write your code, but in one class, if you write the equality logic in one method name, it becomes very difficult for others to use the code. So that's why one standard method we follow, that is equals. Clear? So Java believes more in standards now. Yeah, Java believes more in standards. So the default implementation of equals is what? Checks the reference. Are you following now? Understanding what they are checking now? If this is the equals method, what they will be checking? This is what they write. Write it beside what you have written just now. Understood? If this is equal to E, what they'll say? Return true. Else, what they'll say? This is the default implementation in class object. Very simple, 2 lines of code they have written. Yeah? So it will be checking the reference. If you are still clear, see in class object they have written it like this. Class object equals is a member of class object now. So if you don't override, which method gets executed? The superclass method. Okay, that was the same thing which was happening here when I was calling equals. I was calling the equals method here, t1 dot equals of t2. What was happening? The superclass logic was getting executed. See here. The superclass logic was getting executed and it was giving me false. If you want, you can still check it out. It says there, even though it contains what? Same values, it will tell they are not equal. So what will we do now? So now we'll open the test class, because see, always if I ask any user to check for equality, blindly he'll call equals. He will not care whether you are overridden or not. Understood? He will not care whether you'll blindly call that. So it's my duty to, means that it's the duty of the person who writes the class to override the equals method. So I'll override now. See this. You're overriding, correct? Huh? So public at the return type should be there, boolean. So this is overriding. Public equals. Is the error? Okay, you have to return the boolean, no? Okay. Boolean b is equal to false. So what you do now? Return b, you tell it off. Okay, now we'll start writing the logic. So what logic I should write? If I have to typecast now. Okay, so if E instance of test. First I am checking whether it's of the same type. If it is instance of so and so, fine. Else we'll return what? False only. Okay, here also in if condition we have to return. Let's see how you write the logic. If it is an instance of test, I will typecast it to test now. Okay. To typecasting, once you typecast, now you check if okay, it's asking directly that if z dot x is equal to this. See here, using this is optional. If you want to use it, else leave it directly. There is no conflict. But just I am showing how to use it. And z dot y is equal to this dot y. B is equal to true. Return B. Else directly you can write else return B. Here return you have to do, but you can put on message sys out sorry pass correct object. So done now how you write the logic. So this is how you write the logic. So this is how you use Eclipse now. Okay, so concentrate more on Eclipse as well as library. So now see the same output t1 dot equals of t2, what did it print out? 1 second. After writing it, see I written the code now. When I call equals, which method executes? This one gets executed. But fine, what is going to do now? Yeah, t1 dot equals. This time what it will do? It calls the overridden method and prints what? They are equal. But if I pass t3, it tells they are not equal. So I have 1000 objects also. Comparing is very easy now. How will you call? t1 dot equals of t4, t2 dot equals of t5, t5 dot equals of t6. You can go on comparing any number of objects. That's the benefit of overriding equals method. It's a standard method. Do not write, see, even if by chance, if I write this in M1 method, there's no issue. It will not give me an error. But which method executes? Superclass method. Understood? Now, the user, if he wants to check equality, has to call which method? See, T2, if he executes T2, now what will happen? It will print not equals. It will not give any error. Understood? But if he calls M1, it will give him the correct answer. It's not that it will not give him. But the user will not be bothered to call M1 method. Blindly look for what? Equals method. That's the standard method. So that's why for checking equality, override in equals only. Do not write the logic in any other method. Clear? So don't write, you will not get any error. But user will blindly call equals only. See now, which one executes? If I use equals, sorry, here you have to change it to equals. Now your logic will execute. That's it. Are you clear? So this is how it's going on to execute. So that's the document now. Let's see the document. See equals. It is overridden to check what? To compare equality of two objects. Next, if you want to compare two primitive values, we can use what? Comparison operator. It compares the values in those variables. Example is this. Clearly I have documented. If you want to do compare reference variables, we have two options. We have two. Okay, it depends on what you want to compare. If you want to check whether they are referring to the same object, then use what? Comparison operator. If you want to check the state of the object, then you use equals method. Okay, that's the same thing now. Comparison operator now. What does comparison operator do? Definitely CJP question, interview question, this one. It compares the reference value of the variables and checks whether the reference variables are referring to the same object. It does not compare the contents of the object, but compares the address of the object. Very clearly I have documented. See here what it is checking. Even though the values are same, it will be printing what? False. Understood? Next, what does the equals method do? Equals is overridden to compare what? The content of the objects or the values stored in the object. Okay, T1 is equal to new test, T1 is equal to new, now see I am calling what? Equals method. If you are overridden, it will be true, else it will be what? False only. Okay, so if you want to compare contents of two objects, then we have to override equals method. If you do not override equals method, the default implementation of the equals method in class object is invoked, whose functionality is same as what? Comparison operator only. Okay, this method is always overridden, this method is already overridden for which one? String class and wrapper classes. You will be seeing that. And the last point, we will be seeing it later. Okay, this method is used when an object is stored into Java collections which use hashing like hash set, hash table and all. Implicitly it will be called equals method. Clear? Okay, that's about equals. Clear? Okay, we'll go with the next method now. Hash code. Okay, it's a very big subject, hash code. Okay, we'll see this. What it is. See, whenever an object is created in the JVM now, you will create an object, class demo, PSVM. Okay, box B1 is equal to new box of 1, 2, 3. Box B2 is equal to new box of 5, 6, 7. You created two objects. For every object getting created in the JVM, okay, this is B1, this is B2, objects are getting created now. For every object there is something called as hash code. For every object there is something called as hash code which is getting generated. Okay, and the JVM will be generating the hash code for every object. Okay, there is something called as hash code. So and that hash code, see this is your W, H and D values are stored. This is 1, 2, 3. This is B2 object. This is B1 object. It will have WH and D, it will have the constructor. It might have volume method. All this is okay. Okay. But this is B1. It might have some address. But every object will have what? One hash code, and the value of that hash code will be stored here. Understood? So the return type of this method is int. Okay. So JVM will be using this address. It will use your address and it will generate on hash code for every object which gets created. The value of that hash code will be stored where? In this hash code method. So you'll be seeing this very clearly later. Right now I cannot give you in-depth information about this hash code method. Later on when I'm dealing collections, in collections there is something called as Java collections. There we'll be going in-depth into this hash code. So it will be returning the hash code value of an object in terms of integer. Understood? One more method, parallelly I should write it off. So this is WHND. This is the constructor. These members will remain. Okay, volume method. One more method from class object would be what? ToString. So return type of ToString is what? String. One more method. It is in class object. See, these are all members of what? Class object. ToString method, what it contains? It returns the hexadecimal value of hash code appended with class name and plus. See here, this I'll be explaining now. See here, when you call ToString method now, it actually prints like this: box plus @ plus hexadecimal. Here it hash code is giving you what? Decimal value. ToString will give you what? Hexadecimal value. Hash code will give you decimal value, and this one will give you hexadecimal value. We'll see it. Value of hash code. So these are very, very important methods. See now, after creating the two objects, if I want, I can print b1 dot hash code. What will it print? Return type is int. You can directly print SOP. It will print you some address in terms of decimal. But the same if I print SOP b1 dot ToString, what it will print? In hexadecimal it will print. That's it. Okay. So that's the return type. You can directly print it. In fact, if you don't print b1.toString also, if you call SOP b1, the same result you are getting. Till now you are printing, seeing the addresses now. How are you seeing the address? SOP t1, SOP b1, you are printing now. If you print SOP b1, ToString method gets executed implicitly. If you want, you can call it explicitly. Here I am calling what? Explicitly. Here we are calling what? Implicitly. Here it will be called implicitly. Here it will be called explicitly. Are you clear? So whenever you call that, okay, means for every object there will be a hash code. This is an information. Okay, slowly we'll see how to use these things later. I'll just override and show you this also. This also will be overridden extensively. Hash code and ToString. Just learn how to override them, and later on we'll see why we override them and all that. Clear? Shall I clear all this? This hash code is a very important method. Understood? This hash code is a very, very important method. We'll see how it will be used. So what does the hash code method do? It returns the hash code value of an object in terms of integer. First I'll show you the output. New package you can create com.cluster.object.hash code. I'll have one hello class here. Just I'll have some variables int x, int y, What members you want to have? Okay, you are having this. All this is okay. See, just see this new class demo. You want main there, hash code demo, you can write. Now see this. h1 dot, so I'll call the method hash code. Directly, I mean return type is int. You can accept it and print, or directly you can print. Now see what it prints. This is the hash code value in terms of integer. Understood? So this is a hash code value in terms of integer. If you want, you can create one more object. So every object will have one hash code. Understood? It will be having this. Next, see this. What is hash code now? It returns the hash code value of an object in terms of integer. Every object in Java system has a hash code. The hash code is a number that is different for different objects. Now you will be having a question, what is the use of this and all that? Right now you will not understand, because this is used when we add this value into Java collections. That time this value will be used. Now we are not using that value. When you start adding your values into some hashing technique, into collections which use hashing technique, there it will be used extensively. So there we'll see it. See, what is hash code now? Hash code is nothing but an identification number for an object which will be used by the JVM to search a particular object among the multiple objects available in the memory. Internally, JVM uses hashing technique as a searching algorithm for searching objects. So whenever we add an element in Java collection classes that use hashing, like hash set, hash map and all that, hash code method is invoked implicitly, which returns the hash code of the object. Slowly you'll understand all this. Understood? This hash code value of the object will be used while inserting the objects into collections. While you're inserting into collections, no, that time this hash code value will be used. We'll see it. If you do not want to use existing hash code generation algorithm, if you do not want to use it, then we override what? Hash code method. We override it. Okay. But hash code is already overridden for which classes? String classes and all that. You don't have to override it for that. But for your classes, when you are adding into collections like hash set, hash map and all that, that time you have to override hash code. So I'll just show you how to override, but it will not be as simple as this what I'm showing you. We'll be writing some good logics there. But end of the day, see, overriding means the int p is equal to 0, p is equal to 999. What will I do? Return PLC. So this is hash code, sorry. Now what you can do? See, now when I call it, my hash code will be called, means my method will be called. It will not use the internal algorithm. Earlier what was happening? The hash code method, no, it was taking the address of the object and generating the hash code value and returning the hash code value. But now it is not using the internal algorithm. It is using my algorithm, my logic. Okay, so it will use our algorithm which has been written here. But we don't write such silly logics. We write more good logics which I'll be showing you later. Okay, so just understand, if you override hash code method, return type of that should be int. How this int value will be generated, I'll show you later. We'll write some good algorithms there. Multiplication and all that we'll write and we'll generate it. Clear? So now JVM will not use the built-in algorithm. It will use this algorithm. So when it is trying to add the object into collections, so hash code method will be called. Now this hash code value will be used. This will be used as the hash code value. This will be used as a hash code value. Clear? We'll see it later. So done. Are you clear with this now? So next we'll go with what? ToString method. ToString method I already told you. Okay. Same thing you can see now. I think I have the box class. I'll just copy it and paste it. Okay, I copied it from this project, pasted there. Okay, we are having it now. So what I'll do, see, generally when you use the box object, see what happens. I'll create the object. Box B1 is equal to new box. Or I think I'll use the test class only, it will be better. It will be easy for you. Same class, see what I'll do, you can override also. Now what I'll do, see if I print only H1, see what happens. Okay, I have to pass some values. Correct now? See, this is the hello class, just now you wrote. Okay, so now I'll print what? Hello H1, so now see what it prints. It prints, see here, class name plus what? At the rate of plus what? Hexadecimal value of the hash code. Hexadecimal value of the hash code. If you want to see this, I'll print. And it will be printing implicitly H1 dot hash code. See this now what happens. So this is the decimal value. This is 999 is the decimal value. This is the hexadecimal value. Okay. I'll comment my hash code method. I'll remove my hash code method. Which one will be called? The one of super class. So see now. This is the default one which is generated. This is what has been the class name. What is the value button? ToString is actually printing what? Class name plus at the rate of plus hexadecimal value of this hash code. Okay, but you might be thinking I'm not calling which one? ToString method. If you want, I'll call see here. The result will be same. H1 dot to string. See, the result is same. There is no difference. Only the thing is it was called implicitly, but now it is getting called explicitly. There is no difference. So till now when you are printing the object now SOP B1 B2, it was printing what? The hexadecimal value of the hash code. Understood? But the thing is, ToString method is getting executed implicitly. The ToString method gets executed implicitly. If you want, you can override what? ToString also. Let's see. So the return type of that is string. Remember that. Public string to. Be careful. Look at the ToString method. T small. ToString S caps. Java conventions. One small mistake you do also. It will not be treated as overridden, it will think it as a new method. So now see, string S1 is equal to, we can return one value like this. I am returning, return correct. Now see, forget the hash code now, just check. What is it printing? What is it printing? Hello and hello only it prints. Understood now? This is hello class. What is it printing? Because you are returning hello, it prints. If you don't override this, what it will print? Hexadecimal value of the hash code. See, it will print hexadecimal. See, this is fully qualified class name. Leave it. But class name plus at the rate of plus hexadecimal value. Yeah. Now see, if I don't override, it's printing that. If I nm means if I override, it will print hello. Okay. So now not only for hello object, if you want you can print even for what? One more object I'll create. Hello H2 is equal to new hello, and then again I'll print what? For both of them it will print what? But the values of H2 I'll make it as 5 and 5. Now see, again for H2 also what it will print? Hexadecimal value only it prints. It's printing 4 times hello hello, nothing else. Now we don't override. See, it is telling return a value of type string, but we don't return such kind of silly values. Generally what we return is, we return the state of the object here. We return the state of the object. Like I mean to say here, see, val of w comma h and b is plus w plus h plus d, like this you can return. Plus width, actually, sorry, the variable name is width there. I've used it, sorry, we are using x and y now, sorry. Value of, sorry, I was thinking I was working box object. X and y is plus x plus return is 1. See, you have to return a value of type string. It doesn't mean that you return such simple values like hello and all. Getting it now? We return such kind of values. Now see, it is more meaningful. Why we override it? So as soon as I print now, what it will print? One is implicit, one is explicit. Leave that. Value of x and y is 10 and 20. One value of x and y is 5 and 5. Like this. You create more objects, it will give more meaningful answers. Clear? So here it is getting called implicitly. Okay, but here it is getting called explicitly. Till now, say, here if you override it, you will never see the hexadecimal value of what? You will never see the hexadecimal value of the address of the object. See this. If you override, till now you are printing like this, h1, h2. If you override, it will not print. Clear? So this is how it gets executed. So these are the 5 methods we have completed today. Of which one? Class object, which one equals, finalize, get class, hash code, toString. 5 methods we have completed. Clone we will be seeing later. When I am talking about cloning, there I will teach you. And other 5 methods related to multithreading, when we are seeing multithreading, we will cover. Understood? So these are the different methods. See, toString method is generally overridden to give a what? String representation to an object. If we override this method to display what actually? State of the object. Understood? Whatever state you want to have, you can display it. ToString method available in class object returns what? String, which is a combination of class name plus @ of plus hexadecimal equivalent of the hash code of an object. Okay, if you want to return your own string representation instead of the default format, you can do by overriding ToString method in your class. This method is implicitly executed on an object when we use the reference variable in print statement. Implicitly it will be invoked. Yes or no? Just now you are seeing it. Okay. So then these are the other, see, this is about toString. These are other methods which are clone, wait, notify and all. Some more methods are there. These methods I will be covering when I am teaching you which one? Multithreading. Clone I will be teaching you later. So we have completed some of the methods of class object and we will be using them extensively now. When we start using them, then you will understand. I just introduce this. So many of you will be thinking why they are used, what is the use of this, or you might be finding it a bit complicated today. But fact is, as we go on using it, you will get the clear picture of it. So right now you don't worry whether you understood or not understood. As you go on using it, you will start understanding all how you use this. Okay, but it is very important that you learn class object in the beginning itself. It's a tough subject, okay, in the library, class object, but it is very essential because all classes are subclasses of class object. Understood? So when we start using, you will understand all this. Clear? So get class method returns what? Return type is class. It will give the name of the class. Then we saw finalize why it is used. They are very simple. Okay, fine. Get class gives you returns the class of the object. Get class. Finalize is the overridden for clearing the resources. Then we saw equals. It is used for checking equality. Hash code method, if you don't want to use existing hash code algorithm, then write your algorithm. That's it. And lastly we saw toString method. It is used for giving a string representation to an object or to, what is that? display the state of the object. To display the state of the object. Timing, you get convinced with this much. To learn it is difficult, but once we start using it, they become very comfortable. Clear? Okay. I think that's it for the day then.